Hello everyone, myself Mintu Kumar Kalita, Assistant Professor of Civil Engineering, Assam Dagda University. Today we are going to discuss about a topic named Unsymmetrical Bending. So, before going to the depth of this topic, first we will discuss a little bit about the introduction part, what it is actually and where we have to use this. So, let's start the introduction part where we will come to know about what is unsymmetrical bending actually is and how we have to find out and what is the procedure about this. So first of all, let us go through about the introduction part. The simple bending theory applies when bending takes place about an axis which is perpendicular to a plane of symmetry. If such an axis is drawn through the centroid of a section, the another mutually perpendicular to it also through the centroid, then these axes are principal axes. Thus, a plane of symmetry is automatically a principal axis. Second moment of area of a cross section about its principal axis are found to be maximum and minimum values, while the product second moment of area, that is integration xy dA, is found to be 0, which we will discuss in the later part how we have to find this. Similarly, all plane sections, whether they have an axis of symmetry or not, they have two perpendicular axes about which the product second moment area is always 0. Principal axes are thus defined as the axis about which the product second moment of area is 0. Simple bending can be taken as bending which takes place about a principal axis moment being applied in a parallel to one such axis. When a section of beam is not symmetrical about the plane of bending, an unsymmetrical bending takes place. That is, in addition to bending due to applied loads, twisting is observed in the beam. Then there are principal axes of the section where the product of inertia is 0. So, what we will learn from this chapter? From the chapter, we will learn principal axis and their direction with respect to central axis of the section, moment of inertia of the section about the principal axis, stresses developed at various points of the section due to unsymmetrical bending, product of inertia of the section about any coordinate axis, position of neutral axis with respect to central axis of the unsymmetrical moments are applied about a convenient axis in the cross section. The plane containing the applied moment may not then be parallel to a principal axis. Such cases are termed as unsymmetrical or asymmetrical bending, which is the main topic of our this chapter. The most simple type of unsymmetric bending problem is that of skew loading of section containing at least one axis of symmetry, as it is shown in the figure below. The axis and the axis perpendicular to it are then principal axis, and thus skew loading implies load applied at some angles to principal axis. As you can see in the figure, there are some different sections like rectangular I section, channel T section, which if we divide into two parts, it will be this exact the mirror image of each other. So these are the symmetrical section. The method of solution in this case is to resolve the applied moment about some axis A into its components about the principal axis. Bending is then assumed to take place simultaneously about the two principal axes. The total stress is given by the following formula. With unsymmetrical section like angle, Z section, etc., the principal axes are not easily recognized, and the second moment of area about the principal axis are not easily found except by the use of special techniques to be introduced in Mohr circle of second moment of area and Lenz circle of second moment of area. Before proceeding with the various methods of solution of unsymmetrical bending problems, however, it is advisable to consider in some detail the concept of principal and product second moment of area, which we will discuss in the later part of this video. So this is the first part of the unsymmetrical bending. We will continue in the next part in the later second video. Thank you so much.